2020 paper 2 question 5. Two events A and B are such that the probability of A is 3/4, A intersection B is a half. Prime the probability of B given that A has already occurred. We give your answer as a fraction in its simplest form. So this is just simply a formula. So the probability of B given A is the probability of B intersection A, which is the same as A intersection B, all over the probability of A. The second letter is always the one underneath the line. Just fill in that the probability of B given A is 2/3. Investigate if the events A and B are independent. Again, just a formula. If they're independent, then the probability of A intersection B must be equal to the probability of A multiplied by the probability of B. So let's see what we can already fill in. So we're able to fill everything in except the probability of B. So that's what we need to find. So now let's use our formula for the probability of A union B. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B if an intersection exists, which it does here. So let's fill in the pieces we know. Filling in the bits we know and rearranging the equation, we find that the probability of B is 2/3. Subbing in our probability for B, we're able to multiply, and we find that a half is equal to 6/12, which a half is equal to a half. So the probability of A intersection B is equal to the probability of A multiplied by the probability of B, hence they are independent. A spinner consists of 4 segments as shown. Each segment is equally likely to be landed on. Liam, Circa, Lee play the game in which a spinner is spun twice and numbers landed are added together. The result is divided by 3 and the remainder is recorded. If the remainder is 0, Liam wins. 1, Circa wins. 2, Lee wins. Is this a fair game? Are all 3 participants likely to win? Justify your answer by relevant calculations. You can do this every way you want. One of the easiest ways is to do a two-way table. The top line will be spin 1, where I can get 1, 2, 3, 1, 1, 2, 3, or spin 2, where I can get a 1, a 2, or a 3. Inside of the results, so for example, if I get a 1 on the first spin and a 1 on the second, I add them to get a result of 2. So this gives me all possible outcomes of the table. Now what I'll do is check what each outcome will be if it's then divided. My second table, I'm going to now divide by 2. So taking my top row here, divide by 3. I'm going to divide each of those by 3. So taking the first number here, 3 into 2 does not go, remainder of 2. 3 into 2 does not go, remainder of 2. 3 into 3 goes once, remainder of 0. 3 into 4 goes once, remainder of 1. The second table, for example, 3 into 2 doesn't go, remainder 2. 3 into 2 doesn't go, remainder 2. 3 into 3 goes once, remainder 0. 3 into 4 goes once, remainder 1. And I continue on that table. So these are remainders. As we can see here, there are 16 outcomes in total. So we can calculate the probability for each of them. So Liam needs a remainder of 0. There's 5 zeros. 5 out of 16. Circa needs a remainder of 1. This is also 5 out of 16. And Lee needs a remainder of 2, which is 6 out of 16. Is this a fair game? No. Lee has a higher chance of winning.